Question 13. We've got another boxy framework here. We're looking for FG. So where's that? That's that member here. Interesting setup of a load-in. So we've got sideways force here of 10 kilonewtons, and there's a reaction of minus 10 here. What's interesting is that we get these two reactions from the sideways force, which cancel each other out. So 2.5 coming up and 2.5 going down. So this is kind of pushing into that pivot, which is then trying to lift off the framework against the hinge in the vertical sense. So we're looking for the FG force only. It makes sense to make a cut through that member and then to use method of sections to try and find FG. So the next challenge is to pause the video at this stage and then try and work out what FG is. How would you resolve it for FG? So the first thing you want to do is, after you're making your cuts, throw half of your framework away. I normally keep the left, don't have to, but I normally keep the left. We're looking for the FG force. So the internal forces that we've exposed is FG, but we've also exposed EG and FH. So how do we kind of ignore them, as it were? We only want to know what that FG force is. We can look at the geometry of the FG. It's coming down at an angle. Notice that if we kind of like imagine this to be the force, notice that that's coming down at an angle such that the hypotenuse here would be root 2 meters. So the angle from here to here, well, what I'm looking for really is cos theta. So swing this force through that angle, make it point downwards. The thing I'm looking for is what's cos theta, and the adjacent is 1 and the hypotenuse is root 2, so it's going to be cos theta equals 1 over root 2. So I'm going to resolve forces going downwards in the y direction, and that will pick out only FG. So FG times by cos theta will be pointing downwards. What else can I see in this diagram that's pointing downwards? Well, actually I can see this thing here, which this arrow is telling me it's pointing upwards, although albeit it's given a 9 minus value. So make sure I stay with those conventions. So I'm pointing downwards, which means I want to make the force to be negative. However, the force value is going to be a minus 2.5, so that should be minus 2.5. So minus minus gives me a plus. Bring it over to the right hand side and make it into a minus again. So we have FG equals minus 2.5. Now let's divide through by the cos theta. The cos theta is 1 over root 2, so let's play around with that. 1 over root 2, what we're going to do with that? Well, we could write our final answer with the denominator with a 2 there, and we have a minus 5 root 2 divided by 2. Put that all into your calculator and you get minus 3.54 kilonewtons. So it's a negative answer, so let's tell the reader that it's in compression.